Okay, so this is 7.4, day 2, and we talked about arithmetic, we talked about geometric, and now we're going to, on day 2, we're going to talk about geometric means. We're going to refer to arithmetic means as well, because that's something you should know, and it's something that maybe you don't. Then we're going to talk about finding the sum of a list of numbers, okay, of geometric sequences. And so here we go. Well, here's the deal. Arithmetic, has a common difference. So like you add the same number to each term to get from one to the next, or you subtract that value to get from one to the next. And so an arithmetic mean, you may or may not have seen what it is, but an arithmetic mean is to find kind of the middle of it. You did it in geometry, okay, where you're like, hey, if you've got two ordered pairs, you can find an ordered pair that's halfway between them. If you're finding the average, that would be a way to talk about it. So average, or the midpoint, so if you have 10 and you have, say, 50, to find the average or the midpoint between those. So if you're like stepping algebraically to say, I'm going to add the same number each way, you add these up and divide by 2. And so you would take 10 plus 50 and divide by 2, and you would get 30. And notice this is you can add 20 to get from here to here, and you add the same amount to get from here to here. So it's kind of like a halfway point. If you're going to kind of add to get from one to the next. And so if you're like walking across a river, that would be the halfway point if you're adding to get from one point to the next point to the next point. So in arithmetic mean, you find it by adding up the endpoints and dividing by 2. Okay. We did that when we did midpoints in geometry as well. And so a geometric mean, so arithmetic mean, okay, that's what you do. You add from one to the next, or subtract. It's going to be a linear type function. Okay, geometric, we're figuring out, is there a way to multiply by the same factor to get from one to the next. And the weird thing is, in geometric means, we find multiple. So finding like a couple like rocks to walk across the river. So how you do stepping stones to go across a river. Sometimes we're going to find what would be those stepping stones. So we multiply by the same factor to get from one to the next to the next. And some of you guys who are super intuitive might be able to see it without doing this math, but I do want you guys to learn how to do this math, because I think it's a good thing to do. And so geometric means are going to be, again, related by multiplication, not adding. Okay, so if you add up the endpoints and divide by 2, that's not going to work here. So geometric, because it's related by multiplication. So let me show you the math of it. So let me get in here real quick. Here we go. All right, I'm in. Okay, so this is how I like to see it. This is term 1. This is term 2, 3, 4, and 5. And we want to find kind of the numbers that sit in between the first number and the last number, so that they would be related by a common ratio. Okay, you multiply sequentially by that same value to get from one term to the next. Those would be the 3 geometric means between 0.25 and 64. So this is how I see it. I take the formula that says a sub n is equal to a sub 1 times r to the n minus 1. Okay, and I'm going to use that in this problem, because we know that the value of a sub 5 is equal to the value of the first term times the common ratio, and that would be to the 5 minus 1. And we know even more than that. We know the value of the first term and the fifth term. So the fifth term is 64. The value of the first term is also 0.25. Not a good 2. All right, and then times r to the 4th. And our goal here is to find the r, so we can use it to place those numbers that sit between those two beginning and ending values. And so to solve this, we're going to divide both sides by 0.25. Okay, and we're going to get 256. I'm going to move over here. We're going to get to 256 is equal to r to the fourth. To solve this, we're going to fourth root both sides. It's in the math button. So r is equal to, and it's even root, so we should put plus or minus on it. So we have two ratios we could use, plus or minus, in this case, 4. So let's try the first one if you just do plus 4. So if you just take the first number by 4, you're going to get 1. Times it by 4 again, you're going to get 4. Times it by 1 again, you're going to get 16. Times by 4, you do get 64. So that's your first route. The other route is if r is equal to negative 4. Okay, I'm going to change colors here. So if I times this by negative 4 instead of positive 4, I'm going to get negative 1. So you go up here. If you times that by negative 4, you're going to get positive 4 again. Okay, so notice the third term is 4 either way. And then the next one, if you times by 4, is going to give us negative 16. It's alternating signs because we're timesing by a negative number each time. And if I times it by 4 again, or negative 4 again, I get positive 64. So one route is the geometric means of being 1, 4, and 16. The other route would be the geometric means being negative 1, positive 4, and then negative 16. So you've got two different solution sets, whether r is 4 or r is negative 4. So it's kind of a cute question. This is one of my favorite things to teach. So hopefully you guys are picking this up so cutely. All right, here you go. So the next one says, give me the arithmetic means between 0.5 and 512. Okay, and so geometric means you're timesing by a common factor, common ratio between each one. So this is again term 1, 2, 3. I was right below here because I can't count sometimes. All right, so we know the value of a sub 6 is equal to the value of first term times r to the n minus 1. So we know the actual value of a sub 6 is actually 512. We know the value of a sub 1 is 0.5. We don't know the ratio, and we know 5. All right, it should be to the 6 minus 1, which is going to be 5, okay? I had to pause this and start over. I wrote it was the other term. Okay, so let's divide both sides by 0.45, divide by 0.5. You get 1,024 is equal to r to the fifth. Take the fifth root. Since this is an odd root, you don't have to put plus or minus. You only put plus or minus on even roots, because if you think about it, if you had x squared is equal to 16, your answer would be plus or minus 4. If you had x cubed is equal to, say, 8, it would have to be positive 2. Okay, so odd roots only have a principal root, or only have one root. Not principal root, they have just one root. Even roots can have plus or minus on their answers. Okay, so take the fifth root of 1,024. We're going to get our ratio to equal 4. So that means there's just one path to get here. So if you times this by 4, you're going to get 2. Times 4 is going to give us 8. Times 4 is going to be 32. Times 4 is 128. And times 4 will indeed get us to 512. So it's kind of cool because it's satisfying that you can see, is it actually going to work? Okay. Now, if you're super intuitive and you know the answer beforehand, I do still want you to show me you solving it, okay? So just show your steps and be thankful you are intuitive. So this is step 1, 2, 3, 4, and 5. Again, geometric means I was looking for a product or a ratio between each one, okay? So if you find the product, you get from one term to the next, okay? So a sub 5 is equal to the value of the first term times the ratio to the 5 minus 1. So the value of the fifth term is 1,250. The value of the first term is 2. And to the fourth. Okay, divide by 2 first. Again, if we're trying to solve, we got to really... Okay, so half this is going to be 625. Okay. 625 is equal to r to the fourth. The fourth root of that is going to be 5. Plus or minus. Okay, so even roots have 2 answers. And so you got to take both roots. So times by 5, you get 10. Times by 5, you get 50. Times by 5, you're going to get 250. And then timesing by 5 again, you get 1250. Now let's do the negative route, okay? Negative route doesn't make it all negative. It makes it fluctuate. So timesing this by negative 5 will give us negative 10. If you times it by negative 5 again, you get positive 50. You times by negative 5 again, you get negative 250. And you times by negative 5 again, you get positive 1250. Okay, so on the negative route, it will fluctuate between positive and negative and end up with the same result as you are expecting. Okay, so if we were in class together, I'd be like, you guys try these ones, okay? Because these are more the same. On the back, we're going to go do something definitely different. So find the 4 geometric means between this and this. And sometimes kids are like, what are you even talking? I don't know what to do. Study this for your quiz. Okay, 243 is the first number, 32. Yes, it can go down in value. That means that the ratio is a fraction. Okay, so 4 of these between here. Okay, so if this is a sub 1, this is 1, this is term 2, 3, 4, 5, and 6. So a sub 6 is equal to a sub 1 times r to the 6 minus 1, or 5. And then we know that a sub 6 is 32. We know that a sub 1 is 243. We know the ratio is, don't know what that is. So divide by 243, so 32 over 243. And then we're going to take the 5th root of it. I lied here. Equals r to the 5. And we're going to get the answer to be 2/3. Okay, if you divide that, if you put that in your calculator, you would get 0.666 repeating. So 2/3 is going to be our answer. Because it's an odd root, there's no plus or minus. So if you take 2/3 of it to get from one to the next, you get 162. You get 108, 72, and then 48. Okay, and that'll get us there. So geometric means between 4 and 9604. You just have to make a picture. 1, 2, 3 little stepping stones. Okay, so term 1, 2, 3, 4, and 5. A sub 5 equals a sub 1, and then times r, we don't know that, to the 5 minus 1. So the 5th term is 9604. The first term is 4. The ratio is unknown, so divide by 4. And you're going to get 2401 equals r to the 4th. You get plus or minus 7. And you can see it's going to have 2 roots. If you times by 7, you're going to get 28 and 196, and then 1372. The negative root would be the first term times by negative 7 is negative 28. Times by negative 7 again is 196 positive. Times by negative 7 is negative 1372. And then it will be back to 9604. Okay. So now we kind of get to the fun part. Okay. Actually, I like the arithmetic and geometric means best, but we're going to get to summation. Okay. The deal is this. Here's what they could do, okay? Here's a geometric sequence. 5, 10, 20, 40. Can you find the sum of the first 25 terms of this sequence? If you just plus them up, so 5 plus 10 plus 20 plus 40 plus 80 plus 160 plus 320, you could list them out, and you've got to find the sum of all those numbers. That would be okay if I just said find the sum of the first 5 or 10 maybe, but if I said find the sum of the first 80 terms of that sequence, you'd be like, maybe I don't want to, okay? So they call it a series, but basically we're going to add up the terms, okay? And so physically adding, it does count, but easier would be the 2 formulas I give here. And they both work. You just have to make sure you remember that it's a sub 1, and then you put a subtraction sign, and you have a sub 1 times r to the n. R is the ratio, n is the number of terms, okay? R equals ratio. So like, what are you timesing by from one term to the next? And then use PEMDAS, and you can use either one depending what you know. And there is another formula for like, okay, find the the sum of all the numbers of this. And because sometimes they converge towards a specific value, you can actually find, what it gets closer and closer to. Okay. And so that's kind of fun too. It's not any harder. It's just a different concept. So we're saving that for next year. But this year, we're going to say, let's look at these problems here. So if this young lady has dominoes, okay, in her first row, she has 1 domino. In her next row, she has 2. In the next row, she's got 4. And the next row is 8. And she wants to know is, okay, if she knocks over 6 rows of dominoes. Now 6 is pretty lame. We could just add them up ourselves, but we can show that it works with 6, and we could try it with like say 50 or something fun. So how you set this up is if you find S sub 6, okay, 6 means the first 6 rows, okay? So that right here, the number of terms to add, okay? And the truth is 4, 5, 6, okay, 16, 32. We got the answer. We just plus those up in our calculator. We call it a day. But let's show that it actually works if we use this formula. Okay, so the sum of the first 6 terms of this sequence here can be calculated using either of the formulas there. So let's just kind of go with the first one, okay? You just take the value of the first term. So I'm going to write it down. A sub 1 subtract A sub 1 times R to the n, and you might want to put it in parentheses over 1 subtract R. Okay, here we go. The value of the first term, which is 1, subtract off the value of the first term times R. R, it looks like it's twice because you're doubling it, to the n. N is how many terms you're going to do, okay? N equals number of terms. Okay, so I want to add up the first 6 terms, okay? I know it's lame. Stop. And it's going to be 1 subtract the ratio. The ratio is doubling, okay? So evaluate the numerator. How do you do that? We've got to do PEMDAS, so 2 to the 6th times it by 1 and then put a subtraction sign. Okay, so the 1, times by 1. But again, it's 1 subtract. And the product of those is going to be 2 times 8, 16, 32, 64, 128. Okay, and so you would do 2 to the 6 times by 1. So that would be 64. Oopsie, I need a pen. Sorry. 64 over 1 minus 2, that's -1. So that would equal -63 over -1. And you can put the whole thing in your calculator as long as you're careful to use parentheses. Make sure you put this power outside the value of R. And you get 63. And so if you add up these values right here, you would get 63 dominoes, okay? So if I'm like, you know what, that's pretty lame. Let's try that with 20. So if I say, okay, let's find the sum of the first 20 rows of dominoes, you would do the value of the first term minus off the value of the first term times R, which is 2, to the n, and we want to find 20, and then over 1 minus R, which is 2. Okay, and again, if R is negative, it could become minus a negative. And if you evaluate this function, this expression, you're going to have quite a considerable amount. You're going to have 104,8575 dominoes. Look at that. Okay, so you wouldn't want to just add those up yourself. Okay, and so it's kind of cool. On the first one, you just have to know the value of the first term and how the terms, how many terms do you want to add up. The second one, you actually have to have the numerical value of the first and the last terms of that sequence, and then you can figure that out. So generally, you're going to probably use the top equation because I don't know that I want to evaluate until the 20th term to figure out what that's going to be. So this next one says, if the value of your first term is 2, okay, and your ratio is 3, okay, you're timesing by 3 each time. You want to find an n is 6, okay. So you want to find the sum of the first 6 terms. So that's kind of weird what they're saying. Sometimes they give you the answer, like on your homework, they'll give you S sub 6, and they'll be like, oh, S sub 6, and they say, oh, that's actually 500 or something, and you put that in its place. Right here, and you'd write the formula and you'd solve for what you don't know. But in this question, we're just working pretty straightforward to say, hey, if we want to find the sum of the first 6 terms, and I know the first term, and I know the common ratio, we can do the first equation, which says take a sub 1 minus a sub 1 times r to the n over 1 minus r. Okay, so let's do the sum of the first 6 terms equals 2 minus 2 to the r is 3, and we want to find the 6th term, and then 1 subtract the ratio, which is going to be 3. And again, if your ratio is negative, it will become minus negative on the denominator. So let's do the either put it in your calculator, make sure you use a subtraction sign here and a subtraction sign here. Don't make them negatives. And if you put it in your calculator, you're going to get 728. Okay. The next thing we should talk about would be sigma notation. Okay. It looks scary. It's what's going on over here on B. Okay. I think what we need to write down first is sigma is a Greek letter that means sum. Okay, so this is just sum. Find the sum. And what they put on the bottom is where to start. What they would say, like start with n is equal to 1 and go up to n is equal to, say, 8. And so you're going to find the sum of the first 8 terms. So from term 1 up to term 8. And so you could technically build the sequence, but the truth is that's what they want you to do. And actually, there's a button in your calculator where you can actually type this in there. You may or may not be allowed to use a calculator in certain classes because it will just kind of do it. But the truth is that if you have an arithmetic equation, you will see a linear equation here. So like 2x plus 5, that would be arithmetic. And you notice the common ratio or common difference would be the slope there. Okay. But we're not going to do that formula right this second. We're going to do geometric. And so what you'll see for geometric is going to be an exponential growth equation. So you're going to see like 5 and then, 2, and then you'll see like n minus 1. And so you can tell like that's going to be geometric because you can see that common factor going on there. And sometimes they're very complicated looking. But the truth is you can start with n is 1 and that put it into this formula here, and that will give you your very first term. And then you plug in n is 2 to get the second term, and you go all the way up until n is 8 right here. So it's between here and here. That's what they want you to find. And so we can look at this problem right here and say, what are they asking us to do? Can we tell what we're doing? So it says start with k equals 2. Okay. Normally you'll see it below the sigma. So we're going to start with term 2. So we're going to start with k equals 2, and then we're going to do k equals 3. We're going to do k is 4, and then we're going to do 5, and we're going to do term 6. Okay. So those are the terms that we're going to do. Okay. And so we're going to actually find 1, 2, 3, 4, 5. And so if you plug in k is 2 to this problem right here, we can get the value of the first term. You do negative a half, and you times it by 3 to the 2 minus 1 or 1. Okay. And so a half times, that's negative 3 halves. So that's the value of the first term. And so we got enough information to actually do this. So if we want to find the sum, and the truth is, how many terms are we going to actually find the sum of? Terms 2, 3, 4, 5, and 6. That's 5 terms. So the sum of the first 5, the 5 terms of the sequence are going to equal, okay, the value of the first term, which is negative 3 halves. Subtract the value of the, notice you see the minus and negative is going to become plus a positive here. And then R, the ratio you can tell is right here in the parentheses, a 3. And then to the k minus 1. So k is 6. Okay, so I want to write down here real quickly. What we're using is a sub 1 is equal to negative 3 halves. N, okay, how many terms are we adding up together? That would be 5, okay? It's kind of weird when we start at term 2 and we're going up to term 6. How many terms are we actually finding the sum of? So N represents how many terms are we actually adding together, okay? So over here would be 5. Okay, over 1 subtract R is 3. If you put this in your calculator, you get the sum of those 5 terms, okay, term 2 through term 6, that's 5 terms, is going to be negative 181.5. And when I first looked at it, I was like, how are we getting a negative when we're adding up a bunch? Because look, if you start with 3 halves as your first term of that values, those 5 values, and you times it by that ratio of 3, times it by 3 over 1, you get negative 9 halves. Times it by 3 over 1 again, you get negative 27 halves. And then negative 81 halves, and then negative 243 over 2. So if you added those up in your calculator, you would get the same exact value. All right, so I think the big thing is when you're doing sums, you want to say n is how many terms you're adding up, okay? A sub 1 is a first term, and R is that ratio between those. All right, well, thank you so much. Have a good day.